Once you have established scalar invariance, you can check for residual invariance. This is the final step in establishing measurement invariance. Residual invariance means that the error variance, which is composed of measurement error and specific variance, or variance that is not shared with the factors, is similar across groups. If you're interested in testing the differences between means across groups, then this is not a necessary step of measurement invariance you need to establish because the residuals are not part of the construct. If residual invariance is not supported, it means that different things apart from the construct are contributing towards the answers on the items in the different groups. To test for residual invariance, you need to constrain the item residuals across the groups to be equivalent. You will keep all constraints that you made when you tested for scalar invariance. If the change in the indices are too great, then it indicates that at least one residual is not equivalent across the groups, and residual equivalence is not supported. If the change in the indices are less than the cutoff values, then residual invariance is supported. What to do if you establish residual non-equivalence? Like before, you can try to identify the non-equivalent item by releasing constraints step by step and retesting the model, or you can just accept the fact that there is residual non-invariance and proceed with the main analysis, such as testing for mean differences. Okay, now let's see how actually to test for residual invariance. You need to right-click or double-click on the residual and click on Object Properties. And in the variance text box, you're gonna write E1, and we're just gonna continue with E2, E3, E4, E5, E6, E7, E8, E9, E10, and E11. Now we just double check that all groups is checked for, which means that the residuals are constrained to be equal in both groups. And we're gonna click on Calculate Estimates and request the text output. And we're gonna look at the model fit indices. The one we're following are the chi-square, comparative fit index, Tucker-Lewis index, and root mean square error of approximation. Like before, we are going to write down these values in our table and compare the model fit indices from this residual model to the scalar model. Now let's do that. Here are the values for the model fit indices for the residual invariance model, and we're going to compare these values to the model fit indices of the scalar invariance model. As you can see in the delta chi-square, delta comparative fit index, delta Tucker-Lewis index, and delta root mean square error of approximation columns, the chi-square is significant, which suggests non-equivalence. However, all of the other indexes suggest equivalence. And so, because 3 out of the 4 indices suggest equivalence, I will conclude that the scale operates equivalently at the residual invariance level.